Oh man, it's time for 6.2 with some exponential functions. Woo! So next thing we're going to do is we're going to check out some exponential functions. So our basic exponential function is this bad boy right here, f of x equals b to the x, where b is our base. It's a positive real number other than 1. And x is any real number. We're going to keep it real on this one. So for exponential growth, that number inside that's being raised to the x, the number that's being raised to the x, represents exponential growth if it's greater than 1. Now, if it's less than 1 inside there, the number that's being raised to the x, it represents exponential decay. All right, so it can be any positive real number other than 1. It could be greater than 1, it could be less than 1, and it will represent two different things, growth or decay. So the two things we're going to worry about when graphing exponential functions will be our y-intercept and whether or not it's growth or decay. So for this first one here, we can look at the equation. First off, we can find out that it's growth. We know that, right? It's greater than 1, so we know it's growth. It's a very slow growth because it's not much greater than 1, but it's growth nonetheless. Now the new part will be our y-intercept, and it says the y-intercept is the constant in front and a number plus or minus. Now we don't have anything added or subtracted out here, but later on we will. So right now our y-intercept for this one is equal to 5. And it's growth. For number 2 down here, our number out front is 2, and our number plus or minus is 3, while 2 plus 3 gives me 5, once again for my y-intercept. That's just a coincidence. It's not always going to be 5. And we know that it's decay. How do we know that it's decay? Very good. It's because this number is less than 1 inside the parentheses. Wow, you're doing great. All right, for this last one, 3. Well, what's my y-intercept going to be? Ooh, I know, it's 0. Wrong, sorry. It's not that. You got to think about it for a second. What's really out in front here? Is it 0? Because if it was 0, then the whole thing would just be gone. What's that little invisible super awesome number that's always out in front but we never remember? Ooh, it's 1. So we get our y-intercept of 1. That's a tricky one. Don't forget it. And lastly, it's growth because the number inside is greater than 1. Let's do some practice because that's fun. All right, let's do number 1 together. So we want to identify our y-intercept and whether it's growth or decay. Well, my y-intercept on this one, and my growth, this one's tricky here. I don't see any parentheses. But remember, the 5 is being raised to the x, so the 5 is our base. This actually decides whether it's growth or decay. So you can actually put parentheses there. That 5 is really the number that's inside the parentheses, so we know that it's growth. Now, how about my y-intercept? Is it negative 6? Ooh, not so fast, cowboy or cowgirl. There's that 1 out front. Don't forget about that 1. So 1 minus 6 gives me negative 5. So my y-intercept is negative 5. Boom. All right, try 2, 3, and 4 on your own, and we'll go over each answer. So let's check these bad boys out. Number 2, dose. We have decay because we have the 0.5 inside the parentheses raised to the x. And then our y-intercept, 12 plus 1 gives me 13. Boom. Number 3. Ooh, haven't seen a fraction in here before, but we know that 1/4 is between 0 and 1. It's less than 1. We know it's decay. Not all fractions are going to be decay because you could have something like 7/3, which is greater than 1. It'd be growth. So don't always assume that fractions or decimals mean decay. And our y-intercept, 7 minus 5 gives me 2. Last one, out in front it's 3/5, but remember for growth or decay we're looking inside the parentheses. That's a 3, so it's growth. And out in front we have the 3/5, which that's our y-intercept, 3/5. So we have nothing added or subtracted over here at the end.